Alright, let's look at the homework 8, problem number 6. Alright, so we have this function f of x that's a rational function, and we want to find the domain. Alright, so domain is going to be, so we need to make sure that the denominator is non-zero. So when x equals 2, the denominator equals 0, so we have to eliminate x equals 2. Alright, let's see, so let's plug it in. So 2. Alright, so let's check the answer. Alright, we got that. Alright, so we want to find the X-intercept. So we want to set this guy equal to 0. Actually, it's pretty easy, right? So we just have to make sure that the numerator is equal to 0. So x equals 0 is the only one. Alright, so check the answer. Alright, we got that. Alright, and y-intercept is going to be, we're going to just plug in 0 here. Of course, so y equals 0 also. So it just go through the origin. So here. So we got that. Alright, next one is we want to find the vertical asymptotes. Alright, so in this case, when x equals 2, there's going to be a blowing up behavior. So x equals 2. Is the vertical asymptote. Right, and the horizontal asymptote, in this case, you can see that the top has a higher power than the bottom, so there is no horizontal asymptote. Right, check the answer. We got that. Alright, then we want to find the increasing, decreasing behavior. So we need to look at the derivative. Right, so let's take the derivative. So f prime of x is equal to, right, so quotient rule. So we're going to square the denominator. So we have x minus 2 squared. Right, and I'm going to bring 6 outside so that the x squared is the top guy. So square the top. So the derivative of the top would be 2x times denominator is x minus 2. Minus top is x squared, and the derivative of the denominator is just going to be 1. Right? So we can pull out, let's see, 6 is already here. Right? X is in common, right? So we have x here. So we have actually 2 of them x there. So I'm going to pull x out. Right? So what's left is going to be, so 2 times x, so 2x. And 2 times negative 2, so it's a negative 4. And the minus x. Right? Over x minus 2 squared. Alright, so we can clean this up a little bit further. So you have, let's see, 6 in front. And x times, right, so this is 2x minus 1 is x minus 4. Right? Over x minus 2 squared. Right? So I'm going to set this guy equal to 0 to find critical numbers. So you can see that we can just set the numerator equal to 0. So it's going to be 0 and 4. Alright, so let's do a number line. So draw a number line. Alright, then tick marks. We're going to have to put 0. And the function is not defined at 2, so I'm going to have to put 2 there. And then also 4. Right? Then we're going to look at the sign of f prime. Right? So plug in anything less than 0, so I'm going to try negative 1. So this is going to be negative. This is going to be negative. Negative times negative is positive. Everything else is positive. So it's going to be positive. Right? And f prime between 0 and 2, so I'll just try 1. Right, so it's a 1 is positive, 1 minus 4 is negative, so this is going to be negative. Right, anything between 2 and 4, so we're going to try 3. Right, 3 is positive, 3 minus 4 is negative, so it's still negative. Right, so anything bigger than 4, I'll try 5. So 5 is positive, 5 minus 4 is positive, so everyone's positive. Right, so we know that here original function is on this interval increasing here, and decreasing here, and still decreasing, and then increasing. Right? So increasing before 0 and after 4. Right? So let's see, so increasing on before 0, so it's going to be a negative infinity to 0, and after 4, so it's a 4 to infinity, and decreasing on, so it's going to be between 0 and 2, and then 2 and 4, right? So let's check the answer. All right, we got that. All right, then we want to find the local extrema. So let's see. All right, so you have increasing turning into decreasing. So you're going to have a local max here. And add 2 is function is not defined, so there's nothing there. And this is decreasing turn into increasing, so this is going to be local minimum there, right? So local maximum at 0, local minimum at 4. So let's see if we can find that. So local maximum at 0 and the local minimum at 4. All right, so let's check the answer. All right, we got that. All right, and we want to look at the concavity. So we're going to look at the second derivative. All right, so we're going to have to take the derivative of this again. All right, so you have f double prime of x, all right, is equal to, all right, so actually I'm going to just rewrite it this way. So this is going to be, let's see, I'm going to write this guy as a 6, and then you have x squared minus 4x, and then you have x minus 2 squared. All right, so let's take the derivative of that. All right, 6 is just a constant. I'll just put it there. All right. Then we have quantity x minus 2 squared, so it's going to be the 4th power. All right, derivative of the top is 2x minus 4 multiplied by the denominator, which is x minus 2 squared, minus, and top is x squared minus 4x, right? Multiply by derivative of the bottom. It's going to be 2 times x minus 2. Right? So we got that. All right, let's clean this up a little bit. So you have 6 is already there, and the common factor would be x minus 2 there, and also x minus 2 there, 2 of them right there. So I'm going to put x minus 2 there. All right, then what's left over would be, I'm going to have to multiply this out. So you have, right, 2x times x is 2x squared. Right, 2x times negative 2 is negative 4x. Right, negative 4 times x is negative 4x. Negative 4 times negative 2 is plus 8. Right, then minus. Right, so you're going to have a 2 times x squared. Right, and a minus minus, so it's going to be plus 2 times 8x. All right, then all over. All right, so you have x minus 2 to the 4th power. All right, so we can cancel one of the x minus 2, so I have to change that to 3. And then we have 2x squared, and then minus 2x squared. And then you have a negative 8x and a positive 8x there. So what's left is just going to be 6 and 8. So it's going to be 48 over x minus 2 cubed. Right? So if you do a number line there, right? Only thing is x equals 2 is the only place here, so it's going to be 2. All right, then we're going to look at the sign. So if you look at the f double prime before 2, so I'll just try 0. So if you plug in 0, negative 2 cubed is going to be still negative. So this is going to be actually negative there. And if you try f double prime of 3 or something like that, so that everything is going to be positive. Alright, so the original function is going to have, so this is going to be a concave downward before 2 and concave upward after 2. Alright, so let's type that in. Alright, concave upward after 2. Was it after 2? Sorry. Yep, concave upward after 2, so it's going to be 2, 2, positive infinity. And concave downward from a negative infinity to 2. Alright, so let's check that. We got that. Alright, then inflection points. We would like to say inflection point is going to be at x equals 2. But unfortunately, when x equals 2 function is not even defined, so there is no inflection point. Alright, check the answer. Alright, we got that. Alright, so let's find the correct picture. Alright, so let's look at let's review the increasing, decreasing behavior. So it's increasing, decreasing, decreasing, increasing. Alright, so let's look at that. Alright, so initially increasing, decreasing, increasing. So A looks good. Alright, B is not looking good, and C doesn't look good. So D looks good. It's between A and D. Alright, and let's see. We're going to have, let's say, concavity is concave down to concave up. Alright, so let's, right, concave down to concave up, and both of them have the same behavior. But here, this one, it actually have a vertical asymptote at a wrong place. So this is going to be the correct one, A. So let's check the answer. We got that. All right, that's it. I hope that this was clear.